This is Professor Miller from BMCC, and I'm going to do a problem about probability today. Suppose a college has 1,000 students. If there are 300 business majors and 200 students made the dean's list, and there are 45 business majors who made the dean's list, what is the probability that a student is a business major or on the dean's list? So for part A, we'll use the OR formula. The probability of A or B, OR means plus. Take the students who meet the first criteria, add the students who meet the second criteria, but then you have to make an adjustment because there are conceivably some students who were double counted. They're in both business major and made the dean's list. So for us, we want the probability that the student is a business major, add to that the students who made the dean's list, and subtract any students who were double counted. There's a little picture that goes along with this Venn diagram. It's called the box is the whole college. If those are the students who made the business major, those are the students who made the dean's list. What I'm talking about at the end of the equation is double counting the ones who are in what's called the intersection. Okay. So business major, what's the probability that the student is a business major? That's 300 out of the 1,000 students. Add to that the chance that the student was on the dean's list, basically 20%, 200 out of the 1,000 students. Now, at this point, we've counted all of these, we've counted all of those, and again, we've double counted the 45 students who are in the middle. Notice that we don't use any formula to compute the probability of A and B. We just count the students who meet both criteria. So 500 minus 45 is 455 over 1,000. Or 45.5%. Done. All right. Part B, more interesting part actually. Are these two events independent or dependent? Understand what that means. To be independent means knowing the outcome of one of the events has no effect on the probability that the other event occurs. You might be tempted to say, oh, knowing the student's major doesn't affect whether or not they'll make the dean's list. But you have to do the math. You don't know one way or the other until you do the math. There are actually two ways of doing that math, at least two. One way would be to use the formula for independent events and check to see if that works. If two events are independent, then the probability of A and B would equal the product of the two events' probabilities. That is, you multiply. The probability that you have two girls, if you have two children, is the probability that your first child is a girl, 1/2, times the probability that your second child is a girl, also 1/2. So 1 out of the 4 possible outcomes of the gender of two children would give you two girls. There's another way, though, and I'm going to use that way. It's more intuitive, I believe. It's using what's called conditional probability. So another way to see if they're independent is to check whether the probability that the student made the dean's list, given that the student is a business major, right, this is read as given that, it doesn't mean divide, it's a vertical slash, it's called conditional probability, is that equal to the probability of the student making the dean's list, not knowing anything about the student's major. That is this information about the student's major relevant in predicting whether or not they made the dean's list? That's why this is such an important idea in statistics. It's that knowing whether whether the information provided here has an effect on this. Does it help us predict whether the student made the Dean's List or not? So we know the probability the student made the Dean's List. That's 20%. 200 out of the 1,000 students in the college made the Dean's List. Now let's look at this one, conditional probability. If I first ask the student his or her major and the student tells me they're a business major, now I'm no longer working from a sample space with 1,000 students. Given that the student is a business major, I know it's one of the 300 students. Now again, from the picture, if they're a business major, then I know they're in this part of the diagram. And now I'm asking, okay, what's the chance that they are in the little sliver in the middle? We know that there were 45 students in that little sliver in the middle, the 45 business majors who made the Dean's List. So is 45 over 300 equal to 200 over 1,000? Answer is no. This 10% of 300 is 30, so this is 15%. Right, 10% plus half of that again. So these are not equal. If those two are equal, then they're independent. If they're not equal here, then they are dependent. Not knowing anything about the student's major, there was a 20% chance that they made the Dean's List. Now that we know that they're a business major, there's only a 15% chance. Those business professors are tough graders. That's really the idea of independent events. That's my little lesson. Oh, by the way, notice that if this had been 60 over 300 would give us 20%, right? 10% is 30. So then they would be independent. Again, you got to do the math. If this had been 60, yes, it is independent. Knowing that it was a business major doesn't change the probability that they made the Dean's List. In statistics, the issue would really be, they're never going to be exactly the same, but just how close do they have to be for them to be independent? Or to say it differently, how far apart do they have to be to know that we can use this one event to help us predict the other one?